Okay, today we will start complex analysis. Just add section. I have to name. What is the name? This main textbook is Conway. Okay.
স্যার রেকর্ডিংটা অন করেছে?
हाँ, today I will recap basic definition. Just 1 minute. Okay. Suppose G, C and to C is a function. This is open subset. F is F is just 1 minute. F is differentiable at a point A belongs to G if limit s tends to 0 f a plus h minus f a h exists. Notation: if the limit exists, then the value of the limit is denoted by f dash a. Thus, if f is differentiable on G, that means every point of G, then f dash G to C is a function. If this is I want to say this is notation and this is another paragraph. Okay, is a function. If this function is continuous on G, then f is said to be continuously differentiable on G. Definition: a function f G to C is analytic if it's if it is continuously differentiable on G. If f is analytic, obviously G is open set. Here, okay. If f is analytic on C, then it is called an so later we will see that if G is open subset of C, then it is differentiable on G, automatically implies it is continuously differentiable. That I want to say that f is analytic even only if, in this instance of this definition, even only if it is differentiable on an open it is just differentiable on that open set. Okay, observation: let f C and f is differentiable at G, then f is continuous A. Proof: very easy. Limit C with delta such that B A delta is subset of G. This happens because G is open. Now limit mod H is continuous. So this implies F is continuous. Okay, this is very easy. Next page. Example, if R2 is differentiable on 0 and R. The analog version F C to C Z goes to mod Z is nowhere differentiable and continuous C. Let A equals to A2. Limit let H belongs to R minus 0. Limit limit 2A square A1 square plus A2 square.
Sir, H can be a non-zero complex number. Why we take only like real number?
After completing this calculation, you will ask this question. Okay, a1 a1 square square. Now again limit s tends to 0, a plus h h equals to limit s tends to 0 So if I go through two different direction to 0, one is from real line, another is from imaginary line, then we will get two different limit. So the limit does not exist. Now please ask your question. क्या है क्वेश्चन, क्या है?
सर मैं बोल रहा था कि लाइक एच को हम कॉम्प्लेक्स नंबर क्यों नहीं लेंगे?
हाँ, कॉम्प्लेक्स नंबर ले रहे हैं ना.
हाँ,
रियल
अभी
नंबर
अभी
इज
सर
ऑल्सो
बता
कॉम्प्लेक्स
रहा था
नंबर.
लाइक दोनों बात से ही ले रहे हैं, इमेजिनरी और रियल।
हाँ, तो अगर ये लिमिट एग्जिस्ट करता है, if it is exist,
हाँ
then you can go through any path
हाँ
of this, so limit will be same. But
यस सर।
so check that the function is next observation. Consider the function f c to c, then this function is differentiable only a single point. 0 belongs to c. Nowhere differentiable on c minus. Again, just do it. So this is an example of a function which is differentiable at just one point. Limit s tends to 0, h 0. If 0, limit limit again same technique. If 0, we go through real line. Put h equals to h bar, then you will get this. Again, if we take imaginary, and this will equals to I. Since not equals to 0, hence the function is not differentiable at so can you give me an example of real function R2R that is differentiable only a single point? Can you give me an example?
Sir, x minus 1 when uh, x is rational and x when x is irrational.
It is differentiable.
Oh, sorry. Defensible at only one point.
Yes, just an analog version of this.
Sir, f of x equal to 0 when x is rational and x square when x is irrational. Yeah.
So okay, you check your function and send me. Okay,
Okay,
डिफरेंशियबिलिटी.
sir.
एक एक लोग एक एक एग्जाम्पल लेके बोल लेंगे तो कैसे मैं चेक करूँ? तो मैं मेरा काम नहीं है चेक करना, तुम लोग चेक करके मेरे को दे दो. तो क्या प्रूफ करना है? ओनली वन पॉइंट डिफरेंशिएबल एंड नो हेड एक्सेप्ट दैट पॉइंट नो हेड डिफरेंशिएबल. ओके, chain rule. Let C and C be analytic function here. Obviously G omega are open C with functions with fg subset of omega. So we can define composition function. Then G compose F, G to C is analytic and for A belongs to G, G compose F dash A equals to G dash F A F dash A. Okay, the proof is very simple. Fix A belongs to G and choose R0 with this is we can find this R because G is open. Let Hn be a sequence with R for all, so that A plus Hn belongs to that G and limit 0. Case 1, suppose f for limit So limit exists, you have, okay, so you can divide because this is not equal. Case 2. So what is the complement of this case? That if z0 equals to if z0 plus hn for some n. Now
এটা
if
কি বলে এফ ড্যাশ জেড নট হবে, যে জিরো লিখেছো।
hmm?
এই যে লিমিট n টেন্ডস টু ইনফিনিটি,
Oh,
হুম,
okay. So what is the complement of this case? Complement of this case is if z0 not equals to z0 plus hn for some n, but if, just 1 minute, just 1 minute, but if it holds for finitely many cases, finitely many n, so after that uh, uh, after some finite terms we can go to case 1. So case 2 is, I write case 2 for fz0 minus equals to fz0 plus hn for infinitely many n. We write as of such that for star, for this case we go back to the case 1. For other case, now limit n tends to infinity z0 plus ln because f is differentiable, so limit exists, and ln hn tends to 0 implies subsequence ln also tends to 0, so limit has to be f just z0. Again, if f z0 equals to f z0 plus ln, apply g on both sides, so we have uh, g f z0 plus ln g f z0 limit n tends to infinity g zero, because this is equal, again given limit exists because g is differentiable at f0. So therefore g compose f, I should write g compose f z0. Okay, because f z0 is 0, so therefore in both case so this is easy just recapitulation of chain rule.
স্যার একবার স্টেটমেন্টটা একবার দেখাবেন এটা
Okay,
স্যার দাঁড়ান দাঁড়ান স্যার বলছি এখানে ওই জি আর সিগমাটাকে কানেক্টেড নেবেন না
না কানেক্টেড লাগবে না,
আচ্ছা
কানেক্টেড শুধু f dash z0 মানে f dash z0 for all z, then f is constant এখানে লাগে।
আচ্ছা ঠিক আছে ঠিক আছে
আমার প্রুফে কোথাও কানেক্টেডনেস ইউজ হয়নি। Proposition let omega be open subset of C suppose f g to c and g omega to c are continuous functions such that fg omega and if z, that means g compose f is identity on g, if g is differentiable and g dash z not equals to 0, then f is differentiable and f dash z g dash fz. Proof. Pick z0 belongs to g and the delta with g. Limit h tends to 0 limit to 0 z0. So h can be written as z0 plus h minus h. Now z0 plus h means g of f z0 plus h, because g of fz is z for all z. f0, this is f not t, f z0, let y0 equals to fz0 and y0 plus k equals to h. Since f is continuous, then on g, then limit h tends to 0, continuous is inevitable here, z0 plus h minus fz0 0. This imply k tends to 0 as h tends to 0, because it is k, right? Therefore limit h tends to 0 sorry k tends to 0 1 by g is differentiable on omega limit exist and g dash mm, z not 0. This imply f is differentiable at 0 and f dash z0 okay. So simple proof, but it is very important theorem. It will be used to show that branch of logarithm is analytic. A region is an open connected subset of C. Okay, some book is called domain. Let G, V and F to C be analytic. Suppose F U I V, where UXY equals to real F IY and VXY, and to write V. Imaginary x plus IY belongs to G. So f dash z equals to limit s tends to 0 fz plus h minus fz h let h belongs to R with delta and G. Limit tends to 0 ux plus h y plus I x plus h y minus uxy so f dash z equals to y h equals to limit s tends to 0 u tell me why I can separate this limit from this line to this line. Please explain. This is my why? Because complex limit exists if real part and imaginary part both exist, if and only if. Okay, just I write here, note that both met exist since f is differentiable. Both limit means this u and v differentiable at z. Okay, again f dash z equals to limit s tends to 0 limit s tends to 0 u x y plus h plus I x y I h. So again we can separate this limit. H and this is equals to both limit exist. We got total limit exist. So I mark it as 1. and it has 2. We get, compare real and imaginary part, we get this is called Cauchy-Riemann equations. The converse part is also true, but it is very long. If you have any question, please tell me. So if it is analytic on a region, then it will satisfy Cauchy-Riemann equation. So connectedness is not needed here for this part, but for converse part we will need mean value theorem and we will need connectedness. Okay, if you have any question, please ask me. Converse part is very long, so next day I will do it. কোনো কোশ্চেন থাকলে বলো। Okay, then I will stop here.